So we're going to do problem 79 that says that x to the third power minus 2 to the second power. You factorize it, you take out the x to the second power, and you will have x minus 2. The degree would be 3 because it's the highest power. The leading coefficient would be 1 because it's next to the highest power. The x-intercept would be 0 because we don't have any other coefficients. We have the x-intercepts, which are 0, 0, and 2 because we have two zeros on the x squared and we have a 2 from the x minus 2. The domain will be all real numbers because all graphs are all real numbers of the domain, and the range will be y is all real numbers because in this case we have an odd graph, and odd graphs have all the real numbers. So now that we have all the information, we can graph it. In this case, we have an odd positive graph, so it will start from down to up. So we start our graph and we go and bump into the 0 because we have an even multiplicity. So we go down and it bumps in the 0 and then it goes up in the number 2, and there you have the graph from down to up.
Okay, we're going to do problem 78. And the problem is x negative x to the second power plus 10x negative 16. The degree would be this one, so it's going to be 2. The leading coefficient, negative 1. The y-intercept would be negative 16. And the x-intercept, to look for the x-intercept, we need to factorize. So we put the negative outside. X2 negative 10x plus 16. Okay, so now A2 negative and negative, so multiplying will be positive 16 and adding will be negative 10. So the x-intercept will be x8 and x2. So we go to x-intercepts. It would be x8 and x2. The multiplicity will be 1. And now we go to the graph. We look for the x-intercepts, which are 8, 5, 7, 6, 7, 8, and 2. Now we look for the y-intercept, which is negative 16, 5, 10, 15, 16. So because of the degree is even and the leading coefficient is negative, both are going to be down. So now we need to pass here it is. Now the domain would be negative infinite, positive infinite. The range would be from 5, no, be infinite to positive infinite.